Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see today's problem. Distribute candies. You are given a root of the binary tree and n nodes where each node contains a certain number of candies and the total number of candies across all the nodes is n. In one move, you can select any two adjacent nodes and transfer one candy to the another node from one node to another node. The transfer can occur between a parent and a child in either direction. Your task is to determine the minimum number of moves required to ensure that every node in the tree has exactly one candy. The test cases are framed such that it always possible to achieve the configuration in which every node has exactly one candy after some moves. So in this question we are giving a binary tree and every node has contained some values, and the sum of every value, all the values will equal to the n. So we need to distribute our candies in such a way that every node will get at least one candy, exactly one candy, not at least, exactly one candy. So in every move, how we can distribute the candies from the parent to child or from the child to parent in any direction. So this is a simple problem. We don't, for example, this. Let's look at this case. We have 5 here. We can distribute one candy to this node, to its left child. So the one move is here. We can distribute one candy here, then here. So there will be two moves for this candy. What we are gonna do is we're gonna move one candy from here to here. So we are required to fill these two nodes. We require 4 moves and one move for this place. So in total we require 6 moves. 4 plus 1 plus 1, 6 moves. So so the solution will be the intuition for the solution will be we're gonna track the movement in a variable, and we're gonna have this we're gonna just figure out how many candies are there for a node, and extra candies will be transferred to the parent node. Let's look at the code here for the more clarity. We have the rest variable which will store the number of moves required to distribute the candies. We're gonna call this solve function. If the nodes is a null pointer, then we're gonna return 0. Then we will be calling this the left for the left node and for the right node. The left and the right have have the number of candies received from the left and the right course knife nodes after fulfilling their needs, which means if for example 2 candies are there at this node and 2 candies are here at this node, then we will have only one candy here, and we will give rest of the candies to the parent node. So the current node data will be current node data plus left and right, and the number of what we gonna say the number of movement will be the current nodes minus 1, because after its full meal after we have this current node data, we're gonna take only one candy here and pass it the next candy to the parent. So what we are going to do is we're going to take the absolute value, because sometimes the value can be 0 like in this case. So we will pass minus 1 here because we require one candy. If we have extra candy, we will pass it to the parent. If we don't have any candy, we will take from the parent. Either way, we are using a one move here. So that's the intuition of the problem. And after that, we're going to pass current node minus 1 to the parent node. So this is a simple like TFS type problem. So and a time complexity will be big O of n, space complexity will be big O of 1. Guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.